Hi Algebra students, thanks for waiting all day for this video. It's worth it. We're going to have a bunch of fun because now we're going to talk about the Pythagorean theorem and we're going to do lots of hands-on and fun activities. So I'm going to get right into the lesson and do that with you first. So I hope you have a piece of paper out and ready to take notes. So this is lesson 11.4. And the Pythagorean theorem is this. Most of you have seen this before, but if you haven't, that's okay. So we're going to go a little faster, but this is the idea. A squared plus b squared equals c squared. Now this is the formula for the sides of a right triangle. So if we have a right triangle like this, I've got my right angle there, and A and B are my two sides, and C is the hypotenuse. So if I know any two of these sides, A, B, and C, then I can find the third side. So here's how it works. Number one, find A. And here is the picture. A, 6, and 7. So I want to find the height right here, this leg of my triangle. So A, I don't know. My other leg is 6, so I'm going to add 6 squared. And then the hypotenuse I know is 7 squared. All right, so let's solve for A. I'm going to work this out. 6 squared is 36 and 7 squared is 49. And then I'm going to subtract 36 from each side, so I get a squared equals 13. Now the reason why this lesson comes up in this chapter 11, it's because we've been working with square roots. And I, as a teacher, as well as every other math teacher out there, wouldn't want you to try to figure this out unless you know how to do a square root. So here, we're going to take the square root, and I get A equals the square root of 13. And again, it depends on the answer in your book, that it might have the square root of 13, or it might not. So just in case you want to use your calculator and figure out that this is about 3.61. Okay, so that's number one. That's how we use the Pythagorean theorem. All right, let's do number two. Now we're going to take it up a notch, and we're going to apply algebra to it. So we're going to write this down, a right triangle has one leg 2 inches longer than the other leg. The length of the hypotenuse is the square root of 10. Find the leg lengths. All right, now again, if you're behind, go ahead and pause the video and write all of this down. I'm going to keep going. Now, this is where the algebra comes in. I have my right triangle. Let's see what I have. One leg is 2 inches longer than the other leg, and I don't know either of them. So I'm going to call one leg X. I don't know it. The other leg is 2 inches longer. So if it was 5, the other one would be 7. If the first leg was 8, the second leg would be 10. It's 2 more. So every time I would be adding 2. So the second length is x plus 2. And then the hypotenuse is always the longest side of a right triangle, and it's across from the right angle. And I know that is the square root of 10. All right, so here's my Pythagorean theorem. And I am going to put those values in. So instead of a squared, I'm going to use x. Instead of b is now x plus 2, and I'm going to square that. And then c is the square root of 10, and I'm going to square that. Of course, what works out nice with that is that the square root and the power of 2 will cancel each other. But we have to figure this out. So I have x squared here. What does x plus 2 squared mean? Well, we have to figure that out using FOIL. So I'm going to write x plus 2 times x plus 2. Hey Johnny, keep it down. They forget when I'm videotaping. Okay, so I'm going to use FOIL. So I have x times x is x squared. X times 2 is 2x. 2 times x is another 2x, and then 2 times 2 is 4. So when I work this out, I get x squared plus 4x plus 4. All right, that is what I put in the right here in place of x plus 2 squared. All right, so I'm going to write all of this in right here. All right, I'm going to erase that now because it's in the way. And the square root of 10 squared is just 10. Now, I want to get an answer for x. And how do I do that? Well, I use everything that I learned in chapter 9 for factoring. So let's work it out. Here I have 2x squared. I'm going to add those together. And in order to factor, I need to subtract 10. So these cancel. I want to have my whole polynomial equal to 0. My equation is equal to 0. Now I'm going to use one of my factoring methods. I could do factor by grouping, maybe magic x, maybe bottoms up. But the first thing I always do is look for common factors. So what is common to 2x squared, 4x, and 6? 2. So I'm going to take out a 2. Okay, so now I don't have to do bottoms up. Whew, that's much better. All right, so I'm going to do magic x on what's on the inside here. So I'm going to put negative 3 up here and 2 down here. And what multiplies to be negative 3 but adds to be 2? That would be 3 and negative 1. Now remember, this will just drop out. So I'll have x plus 3 and x minus 1, and that's equal to 0. Okay? So now I set both of them equal to 0, and I get negative 3. And here I'm going to add 1. Now, I've got negative 3 and 1. Both of those represent x. So I can't have a negative value for a length because I'm using this to find the length of a triangle. The legs. These are actual lengths. And so I'm going to get rid of this one. Hey you guys, I can hear you out there. Please keep it down. It's the end of the day. Okay, so I have x equals 1. So one leg is x, so that's 1. And the other leg is x plus 2, so that would be 1 plus 2, which equals 3. All right, so those are my two answers. Okay, I want you to try a couple. So I want you to find C. And here it is. 5, 12, and C. So go ahead and do that one. And then I want you to do this one. A right triangle has one leg three inches longer than the other. The hypotenuse is 15 inches. Find both legs. Okay, so why don't you pause the video and go ahead and do that. And I'll just keep on going. Okay, so let's do these. I'm going to change colors. And let's do, I'm going to go kind of fast. If I'm going too fast for you, again, pause whenever you need to. But I want to make sure I have enough time here to get everything done. So I'm going to put all of this in. And I get 25 plus 144, check your work. And I get 169 equals c squared. And c, when I take the square root, is 13. There you go. All right, so here I'm going to have a picture of x and x plus 3, and the hypotenuse is 15. All right, so when I use the Pythagorean theorem, I get x plus 3 squared equals 15 squared. All right. Now, I'm not going to write it all out, but I'm just going to keep going. So if I work this out, I get x squared plus 6x plus 9, and this is 225. Check your work on that. And now I'm going to subtract 225, and I'm going to add this at the same time. So I have 2x squared plus 6x minus 216. And of course we ask ourselves, can we factor anything out? I want to get rid of that coefficient if I can, so I'm going to factor out a 2. And I get this, okay. Now if I look at all the factors of 108, that would be 1 and 108, I'm going to do magic x, negative 108, so negative, and 3. How about 2 and 54, does 3 go in? It does, I believe, yes. 24 times? No, more than that. 108 divided by 3 is 36. 4 and 27. 5 doesn't go in. Does 6 go in? Nope. 7 doesn't go in. 8 doesn't go in. 9 does. 9 times 12. Okay. Which one, if I have one of these being negative and one being positive, will give me positive 3 in the middle? Well, these right here. So I have x minus 9, and this will drop out, and x plus 12. Okay? So I have x minus 9 equals 0, x plus 12 equals 0, and I get 9 here. I hope you're checking your work. And I get negative 12, can't use that because that's negative. So then my one leg is 9, and the other leg is 9 plus 3, which is 12. So those are my two answers. Okay, I'm going to do one more problem with you on our own, and that will be number 3. Sorry, moving that up and down. I'm just going to tell it to you. A pool has dimensions, a pool, doesn't that sound like fun, of 30 and 60. How far do you swim across the pool? Well, if it's a pool and it's rectangular, I've got right angles here. And if I swim diagonally across the pool, I'm going from one side to the other. Well, what does that create? It creates a right triangle. And if I have a right triangle, then I can use the Pythagorean theorem. And c squared would be my diagonal. So I have 60 squared plus 30 squared equals c squared. So I get 3,600, 900, and I get 4,500. And if I take that, I get approximately 67. Okay. All right. I'm going to just go over one more thing. We want to tell whether the sides of a triangle make it a right triangle. Okay? So let's say I have these 3 lengths. So I know those are 3 lengths. Now that could be a triangle that looks like this. Maybe it's 8, 15, and 17 like that. Or something like this. And this was 17, 15, and 8. That doesn't look too accurate, but you get the point. You could have 3 sides that make a triangle, but we want to know if it's a right triangle. If it's a right triangle, then the Pythagorean theorem works. All right, so then I can use this. Well, these 2 are the short sides because they're shorter than 17. And so 17 would have to be the hypotenuse. So it would have to look like that in order to work. So I know 8 is one leg, 15 is another, and 17 would have to be the hypotenuse. Is it a right triangle? Well, let's see. 64 plus 225. Does that equal 289? Yes, it does. So that works out to be a right triangle. Okay. I'll just tell you what the homework is, and you can write it down. The homework is page 740 through 742, numbers 3 through 27 odds, 33 and 35. Okay, now I'm going to come back on. Now here's where we're going to have a little bit of fun. Hey girls, I need your help. I hope you got the worksheets that I sent home to you. They should look like this. Okay, it was blank like this, and I told you to color it, these colors, and I also said in the email this morning that you should cut them out. And now I want you to use them. Okay, so follow me over to my desk here. My dining room table, actually. And I want you to set them up. Now I have my colored paper, so that's what we're going to use. And this is how we're going to do it, okay? I have a right triangle, and I'm going to write on this. So that's my right angle. Can you see that okay? The pink, or not really?
Yeah.
Okay, and this length is going to be A, and this length is going to be B, and this one is going to be C. Okay? Actually, let's use a darker marker. Here's...
Oh, perfect.
Do you have black? Okay, great. I have my 2 lovely helpers, Nicole and Shanae. You will see them soon. Okay, so you should write on your triangle in a dark color so you can see it. Now, what does A represent this length? If I want to represent A squared, what would I do? I would have one side being A and another side being A. And a squared would represent an actual physical square. All right? Now, how about b? If I have the length b, this would also be b. And if I wanted to square it, it would have the same length over here. So b times b would be b squared. This whole yellow square would represent b squared. And obviously, for my long purple one, here's c, the length here on the hypotenuse, the same length going this way, so it creates a square with two sides the same. This is c squared. So a squared, which represents the pink, plus b squared, which represents the yellow, should be equal to c squared, which is the purple. They're actual squares. Now, I want you to prove it. So what I want you to do now is to take your yellow one. Now, do you see that there are two lines on there? So what I want you to do is take a pair of scissors and cut along those lines and create 4 pieces. And I'm going to wait just a moment. You can pause the video now, and I want you to go do that. Okay, so we'll wait just a moment until you come back. Now, assuming you're back with all your pieces, what I want you to do, since these two together, the yellow plus the pink, added together are supposed to be c squared, this square. So I want you to see if there's a way you can fit these all on here to show that the pink plus the yellow is equal to the purple. So go ahead and pause again and see if you can figure it out. Get your family members in on it too. I want you to teach your mom and dad this. Okay, so we'll wait for a moment. All right, so now I'm going to show you the answer. It's a little bit tricky. If you turn the a squared on an angle, and then you use the yellow to make your corners, you can actually fit it on there, like this. And there we go. And this is a visual puzzle, it really does fit, believe me, that shows that a squared plus b squared actually does equal c squared. All right, now we can't just have a puzzle. We have to do some other type of real world example. So let's go back to the computer. You can put that right back on the stand. I want to show you a video. Now, this video is, hang on, whoa, stop. No, I don't want a free one. Okay, they always want to give you a free trial, don't they? All right, now this video, I want to set it up. This is the longest video in North America. I've actually been on this.
Longest Zipline.
Zipline. What did I say? Video? It feels like it. Anyway, okay. This is in Canada, and we went, and I want to show you to see just how cool this is. It's awesome. Ride the Sasquatch. Okay, we did. Now, just to prove it, I have a picture. And there is my daughter, Nicole, at the top, ready to go. And here she is. Oh, no, where is it? Where's the next one?
Oh, you're drawing on it instead.
I know. I'm drawing on it. I'm drawing on my daughter. Where's the next one? Okay. Well, let's see if I can find it. Come on. It's not there. Just be patient. We're getting close. There we are. And there she is, going down the mountain. I don't remember who this was. I think it was my brother. But that's her. Now, what we're going to do is, we're going to talk about, hang on.
Yeah.
Don't go anywhere yet. We're going to talk about what it takes to make a successful zip line. If you're going down that, you want the zip line to be exciting, right? So it has to be steep enough. But you also don't want to die. So it has to be flat enough. So where is that right in the middle that's going to make an exciting ride that is safe, right? So we can't just do trial and error to figure this out because human life is at stake, right? And I value your lives too much for that. But there's somebody I don't value their life, and that is Barbie. So what we're going to do is we're going to go outside and see if we can figure out how to create a great zip line. So here we go. Okay, I hope we have everything. We're going outside to my front yard. Some of you have been out here already. Okay, now here's our demonstration. Look up there. Say hi to Nicole, everybody. Hi, Nicole.
Hi, Nicole.
And who's that? I'm Barbie. How does Barbie feel about going down the zip line? I don't want to do it. She's scared. Ah! Well, look at here. I have Woody. Now look at Woody. Woody, how do you feel about going down the zip line?
Really bad.
He looks really kind of wooden. I don't know. So anyway, what we're going to do is, not today, I'm just setting it up for you. We're going to have Ariel and Woody come down this zip line. Can you see the cord there? The twine?
Mm-hmm. Kinda.
Okay. Now, I want to show you also, coming close, that on the ground here, I have measurements. So if we put our twine here, it's 5 feet away from the vertical distance coming down that's perpendicular there. Does that make sense?
Yes.
Okay. And if we had 10 feet away, our zip line would look about like that.
Oh.
Okay, let's go all the way to 25 feet. Our zip line would look like this. Now that might work out well and it might not. We just don't know. Okay, so we're going to go inside and I'm going to tell you a little bit more about what your assignment is right now. See you later, Barbie. See you on Wednesday. Bye. And maybe Woody will get a little bit more excited. Come on inside. All right. Now, thank you, Shanae.
Oh, there we go.
Okay, great. Now, the other paper that I sent you says Barbie zipline here. Now, I'm going to tell you, you saw the balcony. The height from where Barbie will start to the vertical distance down on this paper, I hope you can see it, is 12. It's 12 feet down, okay? What I want you to do, let me see if I can see this. Okay. What I want you to do, there's a little bit of sun coming in, is pick 3 different lengths horizontally that you want the zip line to be away from the house. So like I showed you that where 5 feet was, where 10 feet was, and where 25 feet was. You can pick those 3 lengths. Or you can pick something else. If you want Barbie to die, you can pick 2 feet. It'll be more like a bungee cord. Or you could choose 30 feet or 20 feet. And what I want you to do is pick 3 lengths that are along the ground and then calculate the length of the zip line, which is the horizontal distance, because it makes a Pythagorean, triple, or a right triangle. Do you all see that? Okay. So this is 12 feet here, and I want you to pick 3 lengths here, and then calculate our diagonal distance, which is the zip line. All right, I will write all those directions out again, and we will talk more about creating a zip line and seeing if Barbie stays alive on Wednesday. Have a great night. Bye.